All right, next up, we're going to talk about 5-number summary and box plots. So a box plot, which is also called a box and whisker plot, is a method for graphically displaying 5-number summary. Plot consists of a rectangle whose left and right-hand sides are corresponding to Q1 and Q3, which we'll talk about later. And the box is divided by a line segment at the location of the median, and then the whiskers are the line segments that extend to the max and the min values, okay? So the median, we kind of already talked about, divides a data set in half, and the median of the lower half of the data is called the first quartile, the Q1. So once you split the data in half, you take like the median of the first half. And then you also take the median of the second half, and that's the Q3. And then you have the min and the max value. So you can see they did it here. And so they have a data set. They worked out the median number first. It was a single number 10. And then they took the median of the first half, which was right in between 2 and 4, you can see there. Actually, let me color code that. I'll go ahead and do that in. So if we're looking at the first half of the data here, the median would be 2 and 4. And if you're looking at the second half of the data, the median would be right in between 16 and 20. So then they identify the Q1 as 3, which is the number right in between those. And then they identified the Q3 as the 18, which is the number right in between those. Okay. Cool. So that is how they got that. And then obviously the min is 1 and the max is 31. So we have another data set here is given. So we're going to go ahead and sort these numbers out. Or are they already in order? No, they're not. Okay, so I'll go ahead and do that first of all. So I need to do the smallest number first, which is 21. So we got 21 as our smallest number, then 22, 22 again. Oh man, I'm gonna need more space than this. All right, so we got 21 as our smallest number. We have 22, 22, 24, 24. All right, and then I have a 25 in there. 26 and 26 again. And a 27. 28. 30 and then 31. 34 and 34 again. And I still don't have enough room. And then 35, 37, 38. Okay, cool. So we'll start counting in here. Find our median. So I have 21 and 38, 37 and 22, 35 and the other 22, 34 and 24, 30, the other 34 and the other 24, 31 and 25, 30 and 26, 26 and 28. And so 27 is our median. All right, and then I'll find the median of the first half. So now I got my fingers on 21 and 26, 22 and 26, 22 and 25, 24 and 24, So our Q1 is going to be 24, since the average is 24 and 24 is 24. And then the second half, I got my fingers on 28 and 38, 30 and 37, 31 and 35, 34 and 34. So their average is, again, 34. And then we have our min is 21, obviously, and our max is 38, okay? So you just got to find the box plot that has that. So 26, 27 for the median on this one. That is my median. Okay, that one has a median of 27 as well. This one is not a median of 27. And this one is a median of 27 as well. Okay, so Q1 is 24. This one you could see is 25, so that can't be it. This one could be it. And then Q1 is 23 here, so that can't be it. So it must be C by the process of elimination. All right, we already did this page in part 1 of the video, so let's head down here. All right, so we got class students took the math test. A teacher wants to know whether most of the students are performing at the same level or if there's a high standard deviation, a large variability. So here are the scores. What's class average? So we'll call that part A, class average. So we'll add everything up. 92 plus 95 plus 85 plus 80 plus 75 plus 50 is 477. And we have 6 tests. So the average is a 79.5. And what's the standard deviation? So for this, again, like I said on the previous video, I'm just going to do this in Desmos. So let me write down these numbers. 92 plus 95, 85, 80, 75, 50. Okay, so now I'm just going to go to the STDDEVP. So I have 92, 95, 85, 80, 75, 50. And I get 14.81, let's call it. Okay. So the standard deviation is 14.81. What information does the standard deviation give regarding student performance? How close are the student scores to the class average? So on average, they're about 15% away from the class average. So I would say these are fairly spread out, fairly high variability, let's call it. The average student is about 15 points away from the average. So we have a lot that are above and a lot that are kind of way below. Okay. All right. This one we can rank without rank the sets of data by standard deviation from least to greatest. So the least one would be the closest together. So I think data set C, obviously those data are very close together, so that would be the smallest standard deviation. And then B, I think, is obviously the greatest standard deviation because those are the most spread out, and then A is just in between those. All right, this one they actually want us to calculate it here. So I'll go ahead and calculate the mean here. So this one would be 184 over 5, which would be 36.8. And then this one would be 117 divided by 3, which would be 39. So then obviously I would say this is the B is greater or the A is less than, however you want to look at that. Okay, so now for the standard deviations. I would go ahead and just go to Desmos for that. And I'll do my STDDevP. Okay. So for the first set, I had 32, 35, 37, 39, 41. And then I'll just go ahead and, while I'm here, do the other one as well. So 101, 2, 14. And so you can see this one's about 3, and this one's 44.1. Oh wait, this should be 41. So that's 3.12 and then 44.1. So let's write that again. So for the standard deviation, this one is about 3.1, and the standard deviation, this one's about 44.1. So clearly this one's a lot bigger. I could have probably told you that beforehand, because as you can see, this data is kind of compact, whereas these ones are spread apart. Okay, if I add 2 to all the data values in the previous example, okay, I'm just gonna do part B. It kind of doesn't matter here. So I'm gonna take the data from here, okay, and I'm gonna add 2. So I'm gonna say 103, and then 5, and then 16. And then I'm gonna refine the mean and standard deviation. So the mean is now gonna be, let's see, 103 plus 5 plus 16 is 223 over 3, and that would be 41. The standard deviation is actually 44.1. So the mean has increased by 2, but the standard deviation hasn't changed. That makes sense because the numbers are not any more spread out than they were before. Since I added 2 to all of them, they're just as spread out as they were before, but they're just bigger, so I have a bigger standard deviation. Now, if I double them instead, so now it's 202, 4, and 28, so I'm doubling these numbers instead of adding 2. The mean now would be 234 divided by 3, which would be 78. And if I did the standard deviation, it would actually be 88.2. Okay, and so in this case, they actually both double. So they both double, and that actually makes sense because now you can see the numbers are more spread out because 4 is very far away from 202. And so this one only mean adds 2. Okay, so different effects there on adding versus multiplying a common number to a data set.